that, we are getting to the panel conversation. Now, the I was reminded that the way the structure is, please use your chat box to send in questions. Normally, at this time, I would say I'll start with a few of my own. But I see a couple coming in. One of them is actually connected to the first question I want to get us started, which is 3D IC or heterogeneous integration. And there's multiple different names. Each one of the speaker has touched on that. It's one of the common threads. Right? The question, actually, let's get to that very quickly. The question was, are Cadence tools able to handle 3D IC design? I would answer generally yes, but I would let the CT do a more direct answer there. Go ahead, CT.
Yeah, you are right. Of course, we can do that. But I was specifically say I will not talk too much about technical detail or product details in this open scenario. But we have this tool already announced 2 years ago, followed by the 3D-IC compiler. So 3D-IC design will be one of the like I mentioned in my presentation. I already treat that like a tripod, 3 legs: design, implementation, and analysis. Those 3 key sectors are included in Cadence tool.
Okay. Well, I should add, I would not be doing my duty without adding the synopsis to offer a complete 3D IC compiler solution too. But that aside, right? Actually, this is connected to the question I want to. Again, there's a reason why each one of our speakers touches on this area. Right? The IC design, Moore's law, or the spirit of Moore's law, where you crank more functionality with certain amount of cost thinking, with certain amount of area thinking, like every 18 months, whatever, right? That was the spirit of the Moore's law. It has always been done in the industry with the straight process technology thinking. Now that is well documented, we run into the wall. There are still advanced logic, right? The 3 foundries in the world today, the top 3 are still trying their very hard, different transistor architecture. Nanosheet, GFAT, LFAT, VFAT, the different 2D material. There's plenty of the innovation going on, but it has not really continued that momentum. We know that for a fact. So that's one of the reasons why recently the heterogeneous integration, advanced packaging, where you cramp more things like chiplet, you can lump that into that as well, right? Become a lot more hot discussion. Now, my question associated to the discussion we just had about, we have seen a couple companies, and you guys mentioned that, right? AMD, Intel of the world, or through Apple at it, but it has demonstrated very commercial set usage of the 3D designs in math. But I think it's fair to say, unlike IC design, right, we have not have a broad application. For example, let me put it this way: if I am a designer, or I have some idea in the silicon, especially in the mature node, it's pretty straightforward for me to actually put the design flow together. Right? Many different companies already offer that streamline, and the foundries offer the right PDKs. I just have my own idea, be it a logic RTL or a stack-based specific analog block. I just need to focus on that. The rest of them, I know it's going to work. I just will try that. I don't think anybody can say that unless you are this Apples of the world, AMD's, Intel, that you have this idea. I want to use a chiplet ecosystem. I want to use the 2.5D, 3D to put a system. It's very comprehensive. So my question to the panel, to the speakers is, what do you think where we are in terms of actually broad math access to enable people to explore the system level design like this? What are the gaps, what we should do as the industry? So I'm going to go, the first question, I'm going to go with the sequence of our speaker today. So Jimmy, you were first. Your comments?
Sure. I think we are in the closing. We're very close for the starting beginning of the massive 3D-IC adoption. I think in the early days we have 3D-IC that's used primarily for memory, HBM, and etc. But I think the next phase is we're seeing the trend is that moving to logic stacking and and moving from 2.5D to 3D, which is happening. I think this is driven primarily due to the second phase, which is the mobile demand. I think that's coming. Mobile demand, HPC. I think those are the two major portion of the category of that. Moving towards that, and I think once we actually be able to do more logic 3D-IC on the not a mature node. We're talking about advanced nodes. I think that's very close as well. An advanced node, we're talking about 4 nanometer, 5 nanometer. I think then there will be a massive adoption on 3D-IC. I think that's the beginning already. We're seeing that we have customers are moving for that directions. Right?
Yep. CT.
Yeah, that's a tremendous, excellent question. Actually, I would say 2.5D, as you mentioned, is still the mainstream right now at this moment. In silicon interposer, we have multiple chiplet on top of it, just 2 floor of things. But people are getting into 3 floor very quickly. We have seen customers or requests coming from, just like Jimmy said, not just logic on logic, it will be the memory on logic, because we know there's a memory wall. We have heating as well, right? Because the execution inside the chips, inside the transistors could be very fast, but the memory cannot catch up. So why not stack up 2 dies with a different technology node, say 10 nanometer on top of 7. So one is for memory, one is for logic. Then instead of put them side by side. So and then if we do that, we need to consider, like I just mentioned, that we need to consider concurrent analysis, and people are trying to connect them together, not in the planar XY view. It should be the top up in Z direction things. So that's what we call, given name. Sorry, we have given another name. We call heterogeneous concurrent design. Heterogeneous here meaning different technology node. Homogeneous concurrent design will be, say you have a 10 nanometer technology on top of 10 nanometer. So this kind of a demand and design we are seeing right now, I would say. Yeah, it will getting more, I would think.
Yeah, I just want to have a quick comment that for the 3D-IC, for example, the SOIC coming from TSMC can be on top of the CoWoS, and so it can be a mix and match with CoWoS and SOIC. SOIC may have a same process node, but as mentioned by CT, you can have a different process node, like 5 nanometer on top of 3 nanometer, memory on active die. But the next frontier is active die on top of active die. Maybe we haven't seen anything like that yet, but maybe it's coming out pretty soon. How did you manage the active die on top of the active die? And what's the thermal dissipation behavior? And how did you handle the power integrity and the pressure route, for example? So these are the new problems that designers need to address if they want to go all the way to with a different kind of mixture for the 3D-IC design. But a very good data point is that we see that all the major design houses are designing 3D-IC already for the past 5 to 10 years, especially for CoWoS. And then the 3D-IC vertically stacked dies are coming more and more. Yeah, so definitely no doubt that 3D-IC is coming very fast.
I would say just like you open this box of like a Lego building, people are just trying to use their innovative creativity to do what all the interesting and weird thing I would see. Yeah.
Right. Yeah. So that's great. That's I heard the word starting to explore. I heard the word the top companies are already doing it, and CT is latest comments, Lego box. That was the premises of heterogeneous or chiplet, right? Many people have talked about it. But my question really is about, is it just a rich man's game today? Right? It's only Apple can do it. It's only AMD, Intel can. Like I said, if I'm a startup, I only have some ideas, limited funding, perhaps. Right? I want to do something, but to tap into that ecosystem, or is there an ecosystem? Right? What can we do? The industry, what can we do to make that happen? Comments?
I can have a quick comment here.
Please.
If you look at the offering from the foundries, that they have a fixed Lego, right? Fixed Lego construction. They provide you that a certain fixed design and style, and you can follow. So you don't need to try your new design styles, and so that can be a quick way for the 3D IC adoption for startup.
Another thing is, I think from EDA's perspective, I mean, we need to start quickly address some of the key challenges in 3D IC design. I mean, Norman just mentioned that thermal is a huge challenge, right? You can't really have two dies and really CASPA align them together. And so those are the challenges that's facing, commercialization of 3D IC. Thermal those are huge challenges that I think ANSYS, also Synopsys, are working together on. So those are the key things that the EDA vendors, we're spend a lot of energy on. That's from earlier on. CT mentioned there's three pillar, and that's analysis pillar basically, where it's a very key. We have to get this thermal issue resolved. We have to get our issue resolved. Then the other rest of the part, make it easier for use. For implementation side, you really have to route, you have to do efficient bump planning. You also have to do your TSV insertion properly to have the R issues resolved. So those things that EDA side that we really are working on solutions, and I think with larger companies pushing for that direction, I think this is gonna very, very soon we're gonna see a massive adoptions of yeah.
So we'll see how soon it is, right? The whole concept, 30 years ago we've been talking about, right? Hopefully it doesn't take another 20, 30 years for people to start tapping. Perhaps we have 100-something audience today. For the people are working in the application domain, semiconductor industry, in the system houses, without sharing any of your sensitive IP information. If you guys are outside of the top couple names, the rich guys I was talking about, if you guys are thinking about it, already doing it, that would be very interesting to see where we are as an industry to start to adopt and this kind of technology. So before we leave the 3D IC, because there's apparently many such questions regarding it. I don't think we'll have time to answer all of them, but one interesting one, and it's probably relevant to the audience and what CASPA mission is, right? From a career perspective, what are the good opportunities for graduate students to enter into the 3D IC field? I would extend that for more than just 3D IC, right? Maybe the whole EDA or semiconductor field. I wonder, this time I'll go to the reverse order. Norman.
Yeah, EDA career is extremely interesting because it combines the knowledge of the EE for 3D IC circuit design, and you also need to have a knowledge of the computer science, and most likely the latest advancement of the computer science, right? The AI, ML, ChatGPT, all the knowledge is required. So the EDA is an integrated science. You get to use all kinds of knowledge, including physics, mathematics, computer programming, and theory, and to come out with a new solution. So this is always a very exciting area that compared to all the other areas that EDA, that I highly recommend to all the new entries and graduate students to pursue this EDA career.
Well, CT, you come from a somewhat a non-traditional EDA background. What's your take?
Yeah. I think yeah, just like Norman said, EDA previously starting from place and route and all those 2D create a automatic electronic or design automation. Then recently, like from Cadence and other like Synopsys, is expanded to analysis, multi-physics analysis, and including like ANSYS type of analysis. So it really become broader. So I would suggest grad student, you take your advantage from one cutting point, no matter your major in EE or computer science or even physics, because that's what you have been spending years and get your degree. Then you try to cut into this industry, but later after it, I would suggest you have an open mind to learn more things, just like Norman said. Here I want to raise I learned from the TSMC chairman Morris Chan years ago. He has a speech and people ask him, what are your suggestions to your new generations young men to not be able to replace by a digital robot? And he said it should be focused on a synthesizer. And he suggests that he learned that from another scholar, E.O. Wilson in America. He basically stressed that a synthesizer, you need to combine different multidisciplinary things then to be able to make a interpretation, judgment, pro and con, then to combine to see how it will go. So I would say EDA will be a terrific arena to do so. And starting from what you're good right now, then cut it in. Yeah.
So yeah, so great quote from Morris. I would add, young woman too, right?
Yeah, sure. Sorry about that.
No, that's okay. I try to get my young woman, my daughter into it, but she's already on her way to medical, so that's out of the question. But we do need a diversity and as much of a different sort of idea and talent pool for them.
You can combine medical apparatus with the EDA.
Oh, there you go. There you go.
Yeah, there's a lot of EDA for medical coming up.
Give you an idea. Jimmy, wonder anything to add?
Yeah, I agree with everybody. I mean, Norman mentioned this is the very interesting field with intersection of electrical engineering, computer science, and mathematics, and most recently, I think you've seen innovation in machine learning, ML actually. So EDA is not as same as 20 years ago. I think with ML and machine learning, I think you will see a lot of interesting new things coming up, and we've seen really good momentum on applying machine learning on all aspects of EDA. So I think we need a lot of bright minds to join this field. I think this is very what you learn here is actually applicable very well everywhere else as well.
Right. It's a hard field, to be honest, right? I mean, the speaker, Norman, especially talking about the multi-discipline, but this is where the actually truly innovation comes in. I mentioned at the beginning, we years ago, right? We meaning the EDA industry was trying to quote unquote get the respect. We didn't get the respect. I remember Wally used to be a long time mentor, CEO and chairman, has for many years in different conferences talking about EDA industry as a percentage of what we serve, which is the semiconductor industry. We have been, the total EDA revenue is around 2-something% of semiconductor for 30 years, believe it or not. Yeah, I mean, the line fluctuates a little bit, but that's kind of where it has been. And recent years, there's some uptick, right? I'm sure the semiconductor guys, I used to be that for 20 years also, don't like it, right? They don't want to pay for more. It always comes down to, but comes down to in terms of cost. But where the system complexity is going, how much of the research EDA companies put into to enable the industry keep going in that direction we're talking about, it's tremendous. And there's a lot of innovation and multidisciplinary innovation. So this is actually connected to one of my questions I had was, the EDA startup environment has not been going very strong in the last 10, 15 years. I think when Norman founded the Apache, that's 2001, maybe 5 years before that, during this whole period of time, that's probably the golden age of the EDA startup. We don't have too many of them, right, anymore. There's still a couple, but nowhere near where they used to be. Now, if somebody, a young mind, or a veteran with some good idea to start some kind of EDA stuff is even possible nowadays. And if it is, what a direction, what a suggestion, right, that you guys can provide. Open forum. Anybody can jump in. Norman?
Okay, this is a tough question.
That's why
Yeah,
Norman go first.
because one of the reasons that there are not too many startups now for EDA is that the foundries, right? Foundries need a certification. And 20 years ago, there's no foundry certification. And right now, there's a foundry certification for 5 nanometer, 3 nanometer, 2 nanometer. If you are a startup and you need to involve certification, the foundries may not want to entertain with a small startup, right? That's a serious problem. So the startup that in the EDA area, you need to look at the possible areas, the new area, innovative area. There are a couple startups very successful now. Looking at an area that doesn't need a foundry certification, and you can find a way to come through. There's other needs for the EDA in some areas, and maybe there are some other applications, not only the electronics EDA, but medical EDA that do not have that kind of limitation. So I would say that don't give up, looking at all the possible ways for startup. Startup always come through with an intensive discussion every day for 3 months, then you will have a good idea.
We can all blame on TSMC. No, just kidding. I know that foundries like TSMC are actually working really hard to have a needle system. Each one of them, TSMC, Samsung, now Intel. But the system complexity is getting to the level, indeed, it takes a lot to get a trustworthy and the so-called certification process. But I think at the end of the day, it's about the values, where the direction, where the complexity, where the values, the ideas can bring to the table. This kind of leads to my next question. So this is a little selfish because it's near and dear to my heart. I'm more directly responsible in Synopsys of analog mixed signal. Okay, the analog mixed signal design, has not really had the level, nearly the level of automation for many years compared to digital, and it comes from the productivity as well. But the world, no matter what we digitize the world, no matter what we, the world is analog. Right? There's plenty of those interfaces, to say the least. CT mentioned the memory wall, the computing memory. That's a very analog problem to solve. So I wonder, in terms of analog mixed signal design, from the EDA or automation perspective, right? Where are we going? What can we do to bring the productivity, attempt to bring the productivity or efficiency as we did as an industry for the digital?
Yeah, I'm not sure. I'll start it, but I don't know the answer, Wei Kai. But I kind of echo your comment that, like in cadence, we have this virtuoso in the analog chip design. When digital come up, they say, well, analog goes away. But like I fully concur what you just said. We're still analog creatures before we become digital robots, right? So so you have digital billions of transistors inside your cell phone's chips, but you still need that wire bonding package in your automotive because it can sustain vibration, hot environment things. So I don't think the analog chips will go away, and it has a different focus application space, I would say, than for a big EDA company like Synopsys. Now, right now we have this three major
Top
four
four
major
EDA company.
company. Yeah, just like you just mentioned, it's really hard to have a smaller coming in, but still we can try to combine them. And I believe in your division, you have a lot of activity trying to leverage digital advantage, to complementary to do the things. But I personally, I don't believe analog chips or mixed signal. No, we should focus on mixed signal. The analog should be always there. Then
In fact, I'll argue, with the attention of the productivity gain, right? It's very well measurable on the digital world. The design bottom today is actually on the analog and mixed signal. So okay, there's another question on the from the audience. Very good, very interesting. Let me read this out first. It's about open source. Open source changes the entire software industry. EDA is the still big players playground. We can talk about that. We have a couple big player representatives. It's still big players playground and applicators mental. And do you think open source will change EDA industry in some way soon? Anybody wants to jump in?
I think I'll jump in because I'm not sure is that colleague bringing up this question because we talked about this week, early this week.
There we go.
I don't know if it's him, but we just like chatting about the new startup things, and I think now we see this Chat GPT and other open AI things. We talk about that maybe open source will stimulate more innovation and more activity or energetic activities among this new generation to come up with even better EDA solutions, right? If no new generation cannot have a better, then what's the point? So that's a very interesting aspect. Yeah, I see the value. I see the value because our fundamental infrastructure, I mean, software infrastructure has been decades. That's the thing. So we could be open-minded to welcome that, I would say.
Okay. Anybody else? Norman, Jimmy, comments? I mean, I have, I've been 20 plus years on the user side, so to speak, right? For EDA, majority of it, any software has bugs. That goes without saying. EDA has certainly its own share of it, but it's much more than that. Putting a chip out is a complex system engineering approach, and every step of the way there are issues. There are issues with the tools, which is easily finger pointed to. Usually people first talk about it. There's issues with boundary collateral. There's issues just with the landscape of your spec keep changing. But my point is the support intensive nature of what the EDA industry is has always been has actually going up in my opinion. Now part of the challenge with the open source is who's standing behind it. Right, I think Linux was the open source. It didn't get, at least one school of thought, it didn't get a mainstream adoption until Red Hat started stand behind it for corporate. They say, okay, you don't need to worry, right? If you have a problem, you actually have a call instead of somebody, amateur or as a side job. They may or may not answer your question. So that's a big step, big barrier for open source of the EDA.
Yeah, I think simply speaking, there are too many bugs in the EDA software. and if you encounter a problem using the open source, who is going to fix the bugs in 2 days for you?
Right. Or you know, with a lot of things is on the bug / enhancement side. Right? You know, and our chip schedule is very aggressive. Those are very difficult problems. Okay. Let me see. Sorry. A quick question. Why
I think
mental?
this ChatGPT question is very good.
Okay. Let me touch on that other thing. Mental question is mental is not here. Why? Because there's mental is not a company. That's just kidding. That's the question you need to ask the CASPA later on. Okay, ChatGPT, machine learning, AI. That's another common theme of all our speakers. You know, there are many things we can go with it, right? Many already exist. Now, my question specifically, I don't know if that's what the audience have. I had that question myself as well. Because there are many things people are talking about it. There are many specific examples shown, right? Including my company. I'm very proud of showing some results. But in terms of you know, short-term impact, the new things we are developing that can immediately, not immediately, in the next year or two, can realistically help our semiconductor industry. What are those opportunities? What are the things that we have been off to work
on? First of all, I like the ChatGPT question. I think that's a good, but you know, instead of say interface, I mean, it might be the engine behind it. I mean, that's more the key, because you're probably not going to talk frequently to ChatGPT type in EDA world. Right. But again, the engine behind it, I think there's a good value to gain to have very, very sophisticated AI ML, where early on, we kind of mentioned about the fact is analog doesn't get more attention on digital, but the fact is right now we're you know, there's a lot of talk about remastering, right? I mean, there's equally important for digital analog to be quickly remastering to a different node. There's no, the importance are both the same, right? You can't have a portion of chip that remastered, but the other one cannot quickly. And the fact is right now there's a strong need for develop the machine learning to really help to reduce the remastering to a very quick turnaround time, right? I mean, we're talking about month of work turning into weeks, maybe, and even days, right? I think those are things that can really revolutionize the chip industry. I think you bring a 40 nanometer mature design to 10 nanometer. In a matter of weeks, right? I mean, those are going to revolution. That's going to bring a lot of new things to the market. I think that is something that it requires very strong machine learning that need to get this through. Yeah.
Yeah, we have been looking at ChatGPT since November last year, and it has potentially many applications, right? For example, interactive debugging, customer support. We receive more than 1,000 questions per day, right, from the worldwide customers. And if we have a knowledge base for all the fundamental knowledge of the manual application notes, the previous discussion with the customers, that we can quickly formulate a question and answer to customers' question, like coming from worldwide, including 1,000 questions every day. And if we zoom into a particular product, while users are using a particular product, the ChatGPT kind of technology can provide interactive debugging, interactive help, right? You can say in natural language that what kind of task you want to do, and then the ChatGPT kind of technology can formulate the commands and execute for you. We can use it for writing the application code. Because we are providing API, and we have a lot of API, I'm sure from Cadence or Synopsys or from Siemens. And then how did you help customers to write an API code? like to achieve a certain task they have in mind, and without bug, right? Without creating the bugs. So that can be an excellent application. And there are a lot of Python code that can be written by ChatGPT within a certain domain of an individual tool. And there are many, many other applications that I'm sure the whole industry is looking into it. And this may be a good question for startup as well. If you have a very innovative idea plus your unique algorithm, this can be a very good application.
I'll put a joke, a real joke. I'm preparing a talk 2 days ago internally, and in the beginning, I'm trying 2 weeks ago. I asked ChatGPT which tool I should use for 3D-IC design, Integrity 3D-IC or A. Then it come back say Integrity 3D-IC is a tool of company B. So I immediately said him, hey, you are wrong. Integrity 3D-IC is Cadence tool. And a lot of us, no, we help them to learn. But anyway, maybe they're trying to not to do the advertisement in the industry or not. But yeah, I would say, but that's really useful. And one of my colleagues already mentioned that maybe next year's summer intern, it will save me a summer intern because ChatGPT could give me a tickle code, taking code very good. He asked it. Well, that's true. So I think it depends on how we use it. Maybe my personal bias that I would say, like AlphaGo. If you have a rule, you have a setup rule, then machine can learn very fast. Then they will do the job. Then like maybe future job, a bank teller could be easily replaced. But like Mr. Morris Chan said, a synthesizer, it will take a little bit longer, I would say, because it involves interpretation, judgment, and basically thinking, I would say. But still, it could be doing better than us maybe someday. Yeah.
Okay. Well, the ChatGPT itself, right? That's a very hard latest. Everybody is still. I'm personally still trying to learn what it is. To be honest, there's some of the what I heard is almost like science fiction, but apparently it's happening. So yeah. I want to learn more. But in terms of a general machine learning behind it, right? Part of the fundamental thing is it's based on data, accessible to the data you need to train. Now, together with our previous discussion about the ecosystem of the industry, if you're not top 3, top 4 EDA company, if you're not the top few semiconductor company, and you have a startup and you want to do something, how do you have access to those data? This is kind of in a way analogy to our cloud computing. It was a while ago, 10 years ago, there's a lot of those hype, but nothing happened because some foundries like TSMC would not want to expose their PDK in some cloud environment. But I think, I don't know, before pandemic, I think this is probably 5 years ago, things started to shift. Right, there's some agreement with Amazon. I believe the very first one I saw is AWS and Cadence. TSMC has a agreement, right? They will make that available. Now the cloud EDA, cloud chip design. We just saw a press release a couple of days ago that Marvell is in this. That's for their own internal chip development on the cloud. To make it available, they're working with AWS as well. So that took a while, took 5 years at least to get through that bottleneck. With machine learning, getting the available data to then train the model to do a specific thing. EDA is much more than EDA, I would say, right? We're the ecosystem where we grow to allow those things to happen. I wonder if our panelists have any thoughts on it. Anybody wants to chime in on a prediction on when we can see the again, not to beyond, let's say beyond the top 4 companies, a startup kind of environment that can build some machine learning, actually will have accessible to the data that's necessary to build a model, the relevant data to build a model in a more public fashion. When can we see that? Or is it a necessary condition?
I think that's a tough condition to meet. First, the top tier company, they have to be willing to share some data. And we work with a certain company, they don't want to share the data to cross-share to the data to another company to build a machine learning model, right? And if we are EDA vendor and we are building a machine learning model for a certain application, and we have to use a multi-source of data, that usually doesn't work because there's an NDA in place. Yeah.
Exactly.
So that would be now we need an environment, for example, say facilitated by SI2 or a certain entity that can collect the open data from top tier companies, and then that will facilitate university professors to build a much better machine learning model.
Okay. Yeah, I think it takes. Put it this way, as maybe we still have quite a few people still here, right? For the general public, I think that the main player in this world listen to their main customer. And if you are main customer, you want to push things to happen in the industry, please work with your foundry suppliers to push for those things to happen. I'm not suggesting any names, but that's actually, I think the cloud model, why it happens is because enough of the top tier semiconductor customer pushing to get our main foundry supplier to get over the hurdle and start to look at it realistically, how do we make it secure and then make that happen. So it will take, that's what it takes.
Yeah.
All right, we're coming up on time. This is a very intriguing conversation. It didn't, as any of the panel, somebody said, if we have topics that we all very violently disagree, that will be a very interesting panel. I don't think we get there today, but we have quite a few different conversations. So I find that interesting myself. I hope everybody on the call find that interesting as well. Again, thanks CASPA for the opportunity. Thanks Jimmy, CT, Norman to donate your time, Saturday afternoon time. And thank you everybody for attending. Okay, bye-bye.
Thank you. Thanks.
Thank you.
Thank you.
Bye-bye.
Pleasure.
Okay, thank you. Bye-bye.
Bye.
Great. Thank you. Bye-bye.